Hello?
Yo. Hey, what's up, this?
What's up, man?
How you doing?
Good. You?
Good, good.
Have you
Thinking,
been have you been able to work on it at all?
mm-hmm. The last course, there was like one test left, and I just watched videos and finished it. Then I did the main test. So this is the new course, and it's exploring the Pythagorean Theorem. I don't know. I know I've seen the video. It's like on three-sided, like right-sided triangles.
Mm-hmm.
Well, if you want to look at it yourself, so you can see.
This next thing called? Is it like how we were
Right
doing
here,
exploring the Pythagorean theorem?
Pythagorean Theorem.
Is this the next? Oh, CR9. I see it. Never mind.
Yeah. So like the last one, this is the first one. I did the test for the last one and finished it because we were like at I think like 74% the last time we did it. I did one more pre-test.
Yeah.
And then I just finished the test.
Cool.
Well, that one's done.
So this is the first one for CR9.
Yeah.
So, do you want me to say anything about this, or do you feel like you have a good idea from the videos that you've seen?
Well, I watched one video. He was just showing me like the A, B, and C. The Pythagorean, I think, has the longest line in the triangle.
Mm-hmm.
So like when, let's say there's three numbers, 16, 30, and 34. It'd be A would be 16, then C or B would be 30, and then the biggest number would be, that. And then you gotta, I don't know what they're gonna ask us, That was just a simple video that
that's the yeah. Let me just go over something real quick. But that's
okay.
Sounds like you have the basic idea. But just to say something for like 5 minutes and then
yeah. I don't know what they're gonna ask us. They always have those weird questions.
Right. So let's see. Did it go? Yes. So Pythagorean theorem only works for right triangles. So that means one of the angles has to be 90 degrees. And then the short sides, so those are both the short sides, those are called legs. Those are A and B, or A and B. It doesn't matter which one is which. It's just A and B are the short sides. And then, like you were saying, C is the long side. It's the one that's like some kids used to say, like it looks like an arrow, and so it points to the hypotenuse.
Yeah, that's what I seen in the video. So the guy would always pose the one from that corner to the right, would always be the one. Yeah,
is the hypotenuse. So it could be any other way, like something like this. If this was the right angle, then that would be C and so forth. So
it doesn't matter because it's a right angle. It doesn't mean that it has to be facing the right. It just means
correct. It just means it's the one that's 90 degrees. And then if you have numbers here, it'll work out. If this is like, it only works if it's if the triangle has a 90 degree angle. But if you take this number and square it, and then you take this number and square it, and then add those together, you'll always end up with that number if you were to also square that. So
if it's a right triangle, right?
Yeah, if it's otherwise a right triangle. Otherwise, you can't use this. And this is like what people refer to as the Pythagorean theorem, the a squared plus b squared equals c squared. One problem that they might ask would be doing something like this. Say we're given some triangle, and it tells you it's a right angle, and they say this one's a 4, this one's a 5. Figure out this one. That's maybe a question that they would say. Then you'd figure out, okay, which one is C, because the other ones are A and B. So which one is C? That would be this one, because it's the longest one. So that's my C. This, I could say, is either A or B. Doesn't matter. I'm just going to say A. And then this one, the question mark, the one that we don't know, I'm just going to say it's B. I could switch those around if I wanted to, but it'll end up being the same thing.
Okay.
So if it said, figure out what this side length is, what we could do is kind of plug in our numbers to this. So A is 4, so then A squared would be 4 squared. B squared, I don't know, so I'm going to say plus B squared. I don't know what B is yet, that's what I'm trying to figure out. And then C was 5, so I have to put 5 squared, so equals 5 squared over on that side. Then I try and figure out what B is. So the way I do that is by doing 4 squared, and that would just be 4 times 4. That would be 16. Because it's not 4 times 2, it's 4 times itself, using it 4 times 4, using the 4 2 times. That's what that 2 is. And then plus B squared equals, and then this one would be 5 times 5, so that would be 25. And we're treating this so far in the same way as if we had something like this.
Yeah.
Where we're trying to get the x by itself, but in this case we're trying to get the b squared by itself. So all we do is subtract 16 from both sides, because I want to get this by itself, and it's the thing that's closest to the b.
Same thing, yeah.
Or the b squared, and then so that goes away, and so 25 minus 16 is, I think, 9.
9, yeah.
And so b squared is the only thing over there. And then to get rid of this part, oh, so the 16, it was the furthest thing away. I forgot. So that's what we deal with first, and then the next thing that's, I guess, the next closest to b is that squared. To undo that, like here, we were undoing this addition by doing the opposite. Well, the opposite of squaring something is square rooting it. And that, like, you can think of it as canceling out the square root, which is this, and the square cancel out, and then you get b equals, and then the square root of 9, that's the same thing as saying what times itself equals 9, and the answer to that question is 3.
3, right?
B is 3. So if the question was figure out this side length, we would say that this side length is 3. Does that make sense?
Yeah.
And I mean, a lot of the time, like this happened to be a nice whole number, but a lot of the time when you square root both sides, you'll get decimals. So we'll just be careful of that. But maybe something like that. That's what they're gonna ask. Maybe, we'll see.
All right. Sounds good.
And is this the first set of problems that are about the Pythagorean theorem?
This is the first time I've seen it, yeah.
Okay.
It's the first time I've heard of it.
Right. All right. So it might not even get that far. A perfect square, do you know what that is?
It'd have to be an even number, right? Like 90? If you would have, well, you know.
No. So a perfect,
no, I don't know.
Perfect square means that you can take a whole number and then square it, and then the number that you get from that is the perfect square. So like if you do 2 times 2, that's the same thing as 2 squared. That gives you 4. So then we would say 4 is a perfect square. the number 4.
Okay.
And then like 3 times 3 would be 9, so we would say 9 is a perfect square. 2 times 5 is 10. We wouldn't say that 10 is a perfect square because you didn't square something to get it. You did a 2 times a 5. If you did
So it
5,
has to be one number.
Yeah, one single number times itself equaling something, then it's a perfect square. So like 25 is 5 times 5, so that works.
Oh, okay.
16 is 4 times 4. So that is also a perfect square. Like you could do 16 is 2 times 8, but there is a single number, 4 times 4, that gives you 16. So 16 is still considered a perfect square. So on these ones, like if you know the perfect squares, then it would be easy. Otherwise, you just do 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8. Do it all the way up until you get higher than these numbers, and you'll figure out which one it is by doing that. Does that make sense?
It would be 81, right?
Yeah, because that's 9 times 9.
Yeah, I got it.
Cool.
Yeah, I wasn't sure what it was. I thought it was doing it. I got it now.
And I think the reason they're probably asking that is because the Pythagorean theorem, you square lots of things.
Oh, okay.
Okay. So before we even read the rest of this, it says Pythagorean triple. All that means is the A, the B, and the C for the Pythagorean theorem. The A, B, and C, they're all whole numbers. None of them are decimals or fractions. So, but it also has to work in the formula A squared plus B squared equals C squared, meaning if you plug in the A and square it and then add it to the B when you square it, it should equal the C when you square it. So if it doesn't do that, then it wouldn't be a Pythagorean triple, but we'll see. Leon verified that the side lengths 21, 28, 35 form a Pythagorean triple using this procedure. Find the greatest common factor of given lengths 7. What is he doing? Divide the given lengths by the greatest common factor 3, 4, and 5. Verify that the lengths found in step 2 form a Pythagorean triple. Leon states that 21, 28, 35 is a Pythagorean triple because the lengths found in step 2 form a Pythagorean triple, which explains whether or not Leon is correct. I feel like there's some rule that he's using that maybe we don't know about.
Yeah, because I was looking at his steps. The second one got me confusing.
Divide the given lengths by the greatest common factor, 3, 4, and 5. So the greatest common factor between 21, 28, and 35, the biggest
7,
number,
right?
Yeah, that goes into all of them is 7. And so if you divide, then you get 3. You get 28 divided by 4, you get, or 28 divided by 7, you get 4, and then 35 divided by 7, you get 5. Okay. And then that makes a Pythagorean triple, because if you do 3 squared plus 4 squared,
I see.
You end up with 25, which is 5 squared. But I don't know. I'm going to check to see if the original is a Pythagorean triple, which means I'm going to do, I'm going to say,
21 and 28, right?
Yeah, 21, 28. I'm going to square those individually and then add them together and then see what I get. And then I'm going to square 35 and see if it's the same thing.
Okay.
And It does work.
Yeah. 1225.
I might have to Google this. So the second answer is not right. Any set of lengths with a common factor is a Pythagorean triple. That's not true, because you could say all the same number, they all have the same factors, common factor, but that wouldn't make a Pythagorean triple. Yes, multiplying every length of a Pythagorean triple by the same whole number results in a Pythagorean triple. Is that true? So let me see. 3, 6, let's do. Okay. Number 1 is not true also, because I just tried out something. I can explain that later if you want, but number 1 is not true. Number 2 is not true. None of the lengths of Pythagorean triples cannot have any common factor. Okay, it's got to be the last one. No, the given side lengths can form a Pythagorean triple, even if the lengths found in step 2 do not. Yes, every length. I'm doing that by process of elimination. So I'm going to take a picture of this. I would say choose the last one, and then we can pause it.
I Googled it. You know how they have the.
Yeah, what did it say? Was it different?
The Quizlet app gave me A. Yeah.
A. It says A is the correct answer.
I'm not saying it's right. Yeah, I'm not saying it's right.
Okay, let me rethink it one more time. Yes, multiply every length of a Pythagorean triple by the same whole number results in a Pythagorean triple. I think I tried that. Hold on. If I do 3, 4, 5, multiply 6 times 3 is 18. 6 times 4 is 24. 5 times 6 is 6. Oh, I must have typed it in wrong. Yeah, I guess. The first one. Yeah. Good call.
Well, I just wanted to see what they had to say. This Quizlet one's usually right, but sometimes they don't even give you the answer. It's like it's not this one, you know.
Right.
And then you're stuck in unknown.
So on that one, I'm not even sure like where that's coming from. Maybe that's like a specific rule. But if you already have a Pythagorean triple, what this is saying is, so like a Pythagorean triple, are you clear with what that means?
That's the 3 numbers, right? Like the 21, the 28, and the 35.
Yeah, and it works A, B, and C, and it works when you square them all and add the A squared plus B squared. So if it doesn't work, then those 3 numbers would not be a Pythagorean triple. So this thing is saying if you already know that 3 numbers do make a Pythagorean triple, then you can multiply those 3 numbers by any whole number, as long as it's the same number multiplied 3 times. And then the new numbers that you get, the new 3 numbers that you get, will also form a Pythagorean triple. I guess that's like some kind of rule or something, but yeah, that's what that is saying.
And that's how like you got the 3, 4, 5, and then
yeah, that's why. So 3, 4, 5 is one of the it's like the first Pythagorean triple. It's the smallest one you can get. 6, 8, 10 is also one, but that's just multiplying the 3 by 2, the 4 by 2, and the 5 by 2, and you get 6, 8, 10. So it's following that same rule. So I guess that works. And we can move on to this one, but that's now a rule that I'm thinking of for later problems.
Okay. We'll see if it comes up.
Yeah.
Well, one of them like this.
Do you have any guess on how to answer this one?
It'd be squared, not with that triple or with 3, with 5, or with 1, right?
That's
squared
correct.
would be the 2, right?
Yep. And all it means, like
the 3 one.
Huh?
Like I've seen they've had like a 3 on the side of it, you know.
So yeah, so the 6 squared, that means 6 times 6. You use the 6 2 times to multiply. So for the 6 cubed, that just means 6 times 6 and then times 6 again. So you use the 6 3 times. And then so the 5 would be 6 times 6 times 6 times 6 times 6, or 5 times.
That's all it is.
Yep.
Oh my god.
So like it's a perfect square because you're squaring the number. So 6 times 6 is 36. That's a perfect square because you use 6 times itself. When there's a 3 up there, it's called cubing. It would be a perfect cube. And I don't know what it's called when you have a 5 up there.
Yeah. Good to know that.
Okay. This one might be simple.
So all we have to do is try to add them all up, right?
Well, you do the Pythagorean theorem on them, and if it works,
so it will do the A and B, and then
A, figure out what A is, square it. Figure out what B is, square it. Add those two things together.
For sure, it's not the last one.
A triangular street sign with side lengths 3, 3. For sure, it's not the last one. Yeah.
All right. And it's not the first one.
Yep.
It's B.
Yeah. So I got 169.
Yeah.
When I did it, and then 13 squared is 169. Okay. Oh, tricky.
Is it D?
It is D.
Because it wouldn't be.
Yeah, I looked at the second one. I thought it was that, but it says plus in between, so it's got to be times. All right, not bad.
Yeah, these are pretty. Well, not like crazy hard.
I think one of these is a kind of like a tricky answer, but you try it and you tell me what you think.
Well, I know like 2, right? Before. I know the 1 is just going to be 1. So.
Wait a minute. So a perfect square means that there are 2 other numbers that when you multiply by itself, or it means there's one other number like that you can multiply by itself to get that number. So like you can't do.
Okay, so you can't do 2.
Yeah, 2 wouldn't work because something times itself doesn't end up
yeah.
being 2.
So this is the square already, the perfect square.
Yeah, these answers are or should be the square already. Yeah, there you go.
So like this would be.
Well, the 18 wouldn't work.
Even if you did 9 and 9.
Well, that would be plus 9 plus 9. Yeah.
Oh, you're right. Yeah. Okay, got it.
So it's got to be the same number, and then it's got to be times. So like you're right to think about the 9 and 9, but
yeah, but it got to be times.
Yeah. So a number is a perfect square if there exists some number times itself and it equals the number that you're like trying to figure out if it's a perfect square or not.
So it's only going to be these 2, or am I wrong?
So you're right. It's 16 and 100, but there's the trick one, which is actually number 1 is also a perfect square because 1 times 1 is still 1. 1 times itself.
Yeah, because you did both, right?
Yeah, that's the tricky one.
That's a good one.
So the perfect squares, the first perfect square is 1, and then 4 is next. Because you do 1 times 1, and then you do 2 times 2, and then 3 times 3, then 4 times 4, and all the way up. Forever.
This is a tricky one.
Okay.
Guess we could try to do it ourselves, right?
Yeah. Like from the picture.
Yeah.
Those lengths.
I got mine's incorrect.
Do you want me to? I just took a picture of it. Do you want me to say the answer, then explain it when we pause it?
Yeah. Why does she only have? Well, she has in here inside here, with the 2 outside of here. So
yeah, she's doing it wrong. What way should it be done?
She should square both of them, right?
Right,
and
individually.
And then they should add this guy here.
Yeah, so she added them first and then squared it, but the way you're supposed to do it for the Pythagorean theorem is squaring it first and then adding. So she did it wrong. Yeah. So scroll down and see which best describes Nadia's solution.
So yeah, she's wrong. This it'll be C.
Yeah. So you what did you get for the hypotenuse?
So when doing that, the A plus or whatever, after I squared them both, I got 2,809.
2,809. And if you push, so like you get that on your calculator, and then if you push the square root button, like if you Do you know where the square root button is?
Oh, okay. So I could just what? How would I do it if I got that number? Say.
So 2,809 to do the square root. You just turn the calculator sideways and look
Yeah.
for the little check mark box
X2?
thing with the 2 in the little corner.
Oh, and the X?
Yeah. And then you hit that, and it should give you 53.
Yeah, it did.
And so 53 is the length of the hypotenuse. That's how you do the square root in the calculator.
Nice.
So she should have gotten 53 for the
53.
hypotenuse. But there we go.
So she did it wrong already too, because she's doing the 9 and the 12. I mean the 9 and
Oh,
15
yeah,
instead of
yeah.
the 12, right?
Yep.
Instead the 15 should be out. No, Ariel should have added the 12 and 9 and compared that to the 15.
Yep. The third one? Yeah. Oh, wait a minute.
These ones are the same or what?
Oh, she says subtracted in the second one. But you should.
Oh yeah, you're right. She should have added.
Yeah, you said added, but then you're like hovering over that one. All right. I think that's right. Okay.
So I mean, this is there's a 4 and a 6, right? So it'd be 8 and 36, but
so the way I think you should think about whenever it's asking is something a perfect square is just to do the perfect squares on your calculator. There's a square button as well. It's the x squared. So like you could do 1 and then hit that button, and then it should just give you 1. And then you do. There you go. And you can just run through.
Button. Which was that one?
Huh?
There's a little button on here. You said.
Yeah, it's the one above the square root button. It's just the X and then the 2.
Oh, I see. Yeah.
So you can just hit like 2 and then that
4.
button, and then it does 4.
Oh, okay.
Like 53, and then hit that button, it gives you 2,809. So you don't have to just type so many, but that's how you can quickly run through the perfect squares.
Yeah, no, I was thinking the adding again. That's why I did the 4.
Yeah. Gotta keep that in mind. Which sets of side lengths represent Pythagorean triples? Okay. So here, it would be easy to use the square button, because then you could just do, like if you're checking the first one, you can hit 1 and then the square button, and then it already does it, so 1 squared is 1. That's on your calculator. And then plus 2, and then hit the square button, and then hit equals to actually add them together, and you get 5. But
could get confused, right?
Yeah, it should be 20. It should be you should get 25 if it's going to be a Pythagorean triple, because it has to be that last number but squared.
Yeah, so 1 is the wrong one.
Yeah, the first
one. I got 5. Right. Second one's not either.
That's what I got.
That's the 23rd one. So the third one's one of them.
Yep.
The fourth one's not. It's off by like a couple.
Is it?
Yes, you got it.
I'm
Let's
gonna check
get it wrong.
again.
I'll do it again. 10 times 10 would be 100, right? So let's do
Oh wait, I've seen it wrong.
yeah, because I got 26 times 26.
What do you get? 26?
676.
676.
Right?
Okay.
So I think, and then 676. So that one is one.
There we go. Yeah.
Yeah, I think I did 678 for some reason. Or I wrote down. It's 25. What was that? The next one's not it.
That's correct.
The last one ain't either. Let's see. Yeah.
The last one
53 times 53. 84. Yeah, that's one.
Yeah.
2,809.
Right. I think that was one of the ones that girl should have gotten, but in one of the other problems. Cool.
Oh yeah. Let's see if those dudes got that first one wrong.
I think they got
No,
it
because
right.
you did it again, right?
Yeah, I think they got it. Yeah.
Let's see what's next.
Yeah, we can do the next one. Estimating and comparing square roots. Okay, I think I know what this is. Can I show you something?
Yeah.
All right. It said estimating and comparing square roots.
Yeah.
Okay. So they're talking. So like when they say square roots, they're talking about like say whatever this number is. So this is a square root. This is actually the same thing as writing 6. Yeah? Does that make sense to you?
Yeah. Okay, it's already done.
Yeah. But like maybe they don't evaluate it. So then they just say, okay, this is a square root. They also like square root of 25 and the square root of 100. Those are all square roots. And we can compare them by thinking of like, well, this is just 6, this is just 5, and this is 10. Yeah?
Mm-hmm.
So 6 and 5, if you're trying to compare those, 6 would be greater than 5. So really what they're saying is 36 underneath the square root is greater than 25 under the square root. That's what they're saying when they're comparing square roots. Does that part make
Okay.
sense?
Yeah.
Okay. Then they will probably get a little bit more complicated to where they say, okay, compare, let's say, compare the square root of 25 and the square root of 24. Well, this one is really easy. So when they say compare, they're saying either write this or write this or write that. So this side is greater than this side, or they're both equal,
Okay.
or this side is less than this side. That's what those three symbols mean. So when they say compare, they're saying use one of those three symbols. So that's like, put that some in here. This one is really simple because they both have a square root on them. So we could say that the square root of 25 is going to be bigger than the square root of 24 just by looking at the insides, because they both have a square root on them. So really we could just compare the insides. But what that really is looks like, where's my calculator? This. So 25 square root, that's just 5, we know that. And then 24 square root is 4.8989. I'm just going to say that. 4.8989. So this one turned out to be 5. This one turned out to be 4.89897, something. This is smaller than this. So Pac-Man, you can think of it as Pac-Man. It always eats the bigger number. So 5 is greater than this. So that means this square root is greater than this square root. So far, does that make sense?
Yeah.
Okay, then they'll probably get to something like this. 6.82. Compare that. So put one of these symbols in for, let's say, the square root of 34. Now, if it was the square root of 36, we could do that, and it would just be 6 times 6. Right, so that would be 6. So we would just compare that. But it's not 36. It's 34. So
the 6 point is greater than, right?
Yeah, yes. If this was, like, if you added 2 more here, we would only get 6 when you square rooted it. But even still, this is bigger than 6. So it would go like that. So that's a way to do it without a calculator. If you wanted to do it with a calculator, then all you do is just plug that in, 34, and then square root it. So 34, and then hit the square root button. 5.83 something. So 5.83. So yeah, this is definitely smaller. So 6.82 is greater than 5.83. I feel like that's, at least for some of the problems, where it'll go. So I'm down to try it if you are.
Yeah, I'm done.
Cool.
Besides everyone's that they'll have probably try to trick us.
Yeah, something with like, where did Johnny go wrong?
Yeah.
Okay.
Here we go. So I did it like
Yeah,
you would, right?
you could just
and
do.
I'd say it's C.
Between 0.2 and 0.3. Yep. I'm not like. It seems really easy. You just plug it into the calculator, right?
Yeah, that seems like you're cheating.
I don't know exactly how they want you to do it.
Yeah, but I mean, a lot of these you can use calculators, you know?
Yeah. But yeah.
There's even a calculator right here. Look. Oh, wait, they have it there. They should have it blocked out if they didn't want you to use it.
Yeah, wait, does it, if you click on it, does it pop up or something?
Yeah, I'm pretty sure. Yeah, pretty good.
Do you see a calculator? Because I don't see a calculator.
You don't see it?
Uh-uh.
Yeah, the calculator.
Oh, okay.
It's like another little page that popped up.
All right, well, yeah, C is the correct one. Okay. Yeah, I guess the calculator again. So the difference, do you remember what that means to do?
Divide one to the other, right?
So difference means subtract.
Subtract.
Yeah, so you just take those, put them in the calculator, and then subtract them.
So my numbers must be way off. Because I got 7.33.
What did you do first?
I did the square root of 12.
And what did you get?
That was 3.4641.
Okay.
And then for the 15, 3.8729.
So you do 3.8729 minus 3.464, whatever it was.
Yeah, and I got 7.33.
Did you subtract or did you add?
I might have added. Yeah, because I shouldn't get to say. Yeah, I see what just. What the hell? 4.87 subtracting 9.6. 4.1. So 0.4.
Yeah.
Yeah, I was actually.
The square root of a positive number greater than 1 is less than the number. So that's saying like the square root of 5 has to be less than 5. Is that true? Let's plug it in the calculator. Yeah. The square root of 15 is going to be less than 15.
Yeah.
Yeah. Any number greater than 1 is less than the number. Let's see, the square root of 1.2. Square root 1.09. Yeah. I think the first one is correct. The square root of a positive number is always less than half of the number itself. That's not true.
Yeah, because I did 3 right now. It was 1.7.
Which is more than 1.5, which is half.
Yeah.
Square root of a positive number less than 1 is less than the number. So like 0.5, what is it? What does it give you? 0.5.
0.7.
So it gets bigger when it's... Yeah, if a number is in between 0, like it's a decimal, in between 0 and 1, when you square root it, the number gets bigger. So that one's not right. The square root of a perfect square is not a whole number. By definition, it has to be a whole number. Otherwise, it wouldn't be a perfect square. So that one's also
wrong. That one's wrong.
Yeah. Square root of a positive number less than 1 is between 0 and 1. What if 0.9 square root 0.94 square root? The square root of a positive number less than 1 is is between 0 and 1. I think maybe that's right. 0.001 square
What
root.
does it mean, or what's it trying to say?
It's saying if you, so it says the square root of a positive number less than 1 is between 0 and 1. So,
okay, so it has to be.
Yeah, like a positive number is any number that's bigger than 0. And if you have a positive number that's less than 1, that just means some decimal that's not negative.
It's
so
in
like
between 1, 0 and 1.
like 0.1,
Point something.
0.2, yeah. If you square root any of that, it still stays between 0 and 1, so it still gives you another decimal, and I think that's right, yeah.
Okay.
92. Which number is farthest from 2 on the number line?
So it's talking about the furthest away on the number line.
Yeah. The number. I think they're all, when you do the square root, all of them are smaller than 2. It's just which one's the smallest, because that would be the farthest away.
First, 2.1.
Yeah, that's what I got. Which two numbers does 6.1? Oh, that one's.
I got B for that one.
Yep, me too. I wonder how they want you to do it. I feel like there's a way.
They want you to write it out, you think?
Yeah, to do it. I forgot what it was though.
That's way better this way, I'll tell you.
I mean, doing the calculator is just, that's what you're gonna do anyway, like in real life.
That's true. Yeah, you're not gonna go pull out a pen and pad.
Yeah.
Unless you don't have a calculator.
Yeah.
So the first was wrong because it should be equal to, right? Same. Or is it because
Oh, one of them doesn't have a square root, so.
Yeah, let me do it. So that one shouldn't. That first one is correct, right?
Mm-hmm.
Because it's 1.8. That the square root 1.8 is bigger than 1.8. Or
Wait, no. You said it correctly once, and then you said it wrong after that. So, the square root of 1.8
is bigger than the 1.8.
No, the square root would be 1.34.
Yeah, 1.6.
Yeah, so
this one is correct.
It is correct because the Pac-Man is eating. The mouth is eating the bigger number. The 1.8 is bigger. Yeah. What do you think on the second one?
That one is correct also.
Mm-hmm.
It's 1.3.
Right. Now
and I would assume from the number being bigger here, it's correct.
Yep. Because you're going to square root both of them, so yeah, it's still going to maintain. It's bigger or smaller, whatever.
This one's wrong. Or no. Let's do it. The 1.4 is bigger than the 1.8.
Well, the 1.8 is square rooted, so you get 1.34, right?
So 1.34, and that one is bigger than the 1.3.
Yeah, so that all checks out. Are they all correct? Oh, there's a plus on that one.
Okay, so I have to add those two and see if they're bigger than 2, right?
Yeah, after you square root them though. So like you square root them individually, then add them together.
Well, I guess I don't have to add them all like that. And no, they're not greater than. Well, yeah, they are 2.6. It would be like 2.6 something.
Yeah, it is greater than 2. I guess that's it, right? Let's just check
the last one.
Yeah, let's just because it says select 5. 1, 2, 3, 4, 5. Yeah, but I'm gonna check the last one just to make sure.
Okay. Yeah, I guess it is. It's wrong, but yeah, it's wrong because it's 0.00 some crap.
Yeah, 0.03676, and this one's 0.1. So
yeah,
like 1. Yeah, there's a 0 after the decimal and the 1.9 minus the 1.8. So like 4. Okay, same thing.
Same crap. This one's correct.
Mm-hmm.
Yeah, this was less than.
Mm-hmm.
This one's good.
Mm-hmm.
This one should have an equal sign here, right?
Right, so that one's not correct. Mm-hmm.
The last one's wrong.
Yep.
Those ain't too bad.
No.
Here we go.
Okay.
Oh, I went through.
Iterative process to locate that on the number line. Whatever that means.
Well, I know that it sounds like this one here is correct.
Yeah, he's not right because when you do it in the calculator, it's 0.387. which should be smaller than
Yeah.
0.4. Yeah, Haas is incorrect because the point should be located between. Yeah, that last one's wrong. So, yep. The point square root of x is plotted on the number line. So, looks like in between 10.1 and 10.2. Maybe 10.19 or something. What whole number best approximates the value of x? Huh? Oh. Like if you put in 100 and then square root it, so like put in 100 for x. Yeah, that's okay.
That's what I was doing. So I got the 103 to be
the closest.
Well, no, not yet. I'm gonna try the 104 because it's the 104.
Yeah. Because that's
right when you said that
10.19. It's almost 10.20, 10.20. Yeah. So 10.19. Like if it was more in the middle, then it'd be like 10.15. But yeah, I think that's the right one. Each plot a point to approximate 0.5 square root. Whose is the best approximation?
Say Yermin.
Yermin. Yep. Oh no! Oh, well, it is saved, right?
Maybe. And it should have gone through. Yeah, say. I got your meme though, right?
Yeah. 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 Cool.
Let's see what's next.
Yeah, let's see. Find the hypotenuse.
And that's just.
I think it's what we did at the very beginning, like what I was showing you.
Yeah, that's the angle of that box, right?
Yeah, where you're just using the Pythagorean theorem again. I'm down.
Okay, yeah, we can do it.
You got time?
Okay.
His yard measures 20 feet by 32 feet. So those would be A and B. Or okay. B and A, it doesn't matter which order, but A and B is those two. What will be the length of his path to the nearest foot? So all you do is, well, I'll let you try it. And then.
Right. So I'd say it's 37.7. Mm-hmm. That's the nearest, right?
Yep. Good. And then, so what I did was 20 and then squared. And then 32. Yeah. Squared. So 1,024 plus 400 equals, and then square root. And you get 37.735. So it's 37.7.
Oh, you did you did it right after. Okay. Then I went back and I did the 37 first and 32 2.
Oh, I see. You can just square root it from whatever you got, and then it should give you the hypotenuse. And the same thing.
Yeah, 37 feet.
Mm-hmm. So far, so good. Reach the top of a 15-foot wall. The bottom of the ladder is placed 4 feet from the base of the wall. Do you understand that one?
How long a ladder must have to reach the top of 15-foot wall at the bottom of the ladder, so it's 4 feet from the base of the wall.
So they're just leaning the ladder against the wall, so it makes a right triangle.
Yeah, so there is the 90, right? And that the ladder is the freaking...
The hypotenuse, yeah.
15.5.
Yep.
The first one.
Mm-hmm.
I was wondering about the D, but that's just the dimension, right? So.
Yeah, it's just whatever he's trying to figure out. Our Pytha. What the fuck? Okay. So just putting them in order.
The shortest distance to the one who went the greatest distance. Sorry. Is Arpita's home the freaking hypotenuse or whatever?
Arpita's home.
Well,
so the path.
She had the shortest, right?
So that just means the straight line between the library and Arpita's home. So the line between library and Arpita's home, that's the hypotenuse, and that's her path.
Oh, and so it shows right here.
Yeah, so it's like 6 miles on that bottom, 9 miles on that left side, and then the shortest path from the library to Arpita's home is whatever the hypotenuse is.
So she's the last one, or she's the first one actually, because
it's the smallest. Yeah. Oh, and that's all you need to figure out, I guess, because But that's right, because Colby's is 13.
Colby got 13, yeah. I got her for like 11.1. So.
Something like, yeah. That's what I got. Okay. Okay. Do you know how to do this one?
It's going to be the same, right?
Same, yeah, same idea. And then at the end, you just add them all together.
Yeah.
This one, I think you get a decimal for the answer. It's not like a nice one.
I got 0.1145.
For the length on Broadway?
Yeah. That one's probably wrong.
So, wait, say it again?
0.1145.
Okay, so then you take that, because she ran on 65th Street, which was 0.19 miles. And then she ran on Central Park West. So that's 0.19 plus 0.28 and then plus 0.11, I think.
Oh, so I do.
Because her whole thing would be all of them added together. I'm going to check that.
Yeah, I guess. Right.
Oh, you said 0.1145?
Yeah.
You got to square root that.
Oh, okay.
And then add them all up together afterwards. Because a squared, you did the a squared, and then you did the b squared, and you added those together, and that gives you c squared, but to get regular c, which is the length, you have to square root it. And then I think you get 0.3383.
3, yeah.
And then you add that to 0.19 and 0.28.
.3 would be to the nearest, right?
Well, you got 1.3?
Well, I lost that number. 1.145. Let me write this number down. Plus point. .8083.
You said 0.808?
7, 8.
Yeah, that's what I got. So it's the second one. There we go.
Well, that shit seems a little complicated.
Especially with because they're all decimals. She didn't even run a mile.
I know.
Oh, so how much longer is the hypotenuse? So after you find the hypotenuse, there's more to do.
Then we gotta, yeah. Okay. So this would be the same crap, right? We do the 6 and 6, it'd be 36.
Mm-hmm.
It would be 10.
So 10 is the hypotenuse, right?
So yeah, and then it'd be 4 then.
Yeah, there we go.
It'd be the first one.
Mm-hmm.
Yeah. $26.
Yep. Not bad, not bad. This one's a good one.
Yeah, the calculator really helps.
Yeah.
All right, so he's just trying to find this little guy, right?
Yeah, he's trying to find C. He's trying to
the
find,
difference between.
and then he's going to subtract that number from with the 16. So he's just trying to do the Pythagorean theorem: 16 squared plus 12 squared equals C squared, and then square root that. Squared plus 12 squared. So that he should get 20. Oh, he got 200. Do you see that?
Yeah.
And he should have gotten 20, because if you do square root of 400, it gives you 20, not 200. And then he would have done 20 minus 12 equals 8. It says check all that apply.
So he did this one wrong.
Mm-hmm.
It should be 20 instead of 200. He found the difference between the properties.
Oh, which one's the long leg? The 16. He subtracted 12. So he did it with the short leg. Do you see that? Hello?
Same thing, right? Just the difference.
It froze and it's not sharing anymore. So you gotta share again.
See it?
There we go. So before it cut out, I was saying that he subtracted 12. 12 is the short leg. So that second answer, he found the difference between the hypotenuse and the short leg instead of the long leg. Because the question asked him to find the distance between the hypotenuse and the long leg. Or the longest leg. So that was also one of the ones that you check.
He found the difference between, yeah.
He should have been subtracting 16 instead of 12.
Let's do that. This one's incorrect. And this one's incorrect too.
Right, because it's 16 times 16, not 16 times 2.
Yeah. It should not have taken this. That one's incorrect too, right?
Yeah, they're talking about the square rooting the 400 and square rooting the c squared, like because that's what you did. Like there's that first step, 12 squared plus 16 squared equals c squared. That's the first one. Second one is 144 plus 256 equals c squared. That's the second step. In the third step, to get from the 400 equals c squared, to get from that step to the next one, you square root both sides. You square root the 400 and you square root the c squared, and that's to get rid of that little square, the two exponents. So that is correct. Yeah, that's what you should do. So
that one is correct.
Yeah,
he should have.
But so like you don't check that last one. So I think that's it. Did it say check all? Yeah, it said check all that.
Yeah, check all that.
All right, let's see.
Oh, it was pretty easy actually.
Yeah, that wasn't bad. Let's just see.
It's going to be the same stuff anyway.
Unknown leg lengths in a right triangle.
You want to say something? Go for it.
Yeah, I'll say something.
I mean, I can Google, YouTube, see if I can do another one.
This one's not. It's not that much different. But we'll see. Let me share. So what we just did was like find something like if this was a right angle, we're supposed to find out this side length, like this side length. So yeah, what we just do is 6 squared plus 8 squared equals whatever. Let's say c squared, and this would be 36 plus 64 equals c squared, and this would be 100 equals c squared. And this is the part that I was talking about. You square root both sides to get rid of that, so you get c, and square root of 100 is 10, so this would be 10. It's almost the same exact thing, except for they're going to give you a right triangle. They'll give you the hypotenuse, and they'll give you one of the legs. And they'll say, what's this one? And
you're going to figure out the other one.
Yeah, and so you really just, you call this like A, and then you say A squared plus 8 squared equals 10 squared, and then just start going from there. A squared, you don't know anything, so you just write it down. 8 squared is 64, 10 squared is 100, and then now you're trying to get this by itself. So you subtract 64 from both sides. So you got a squared equals, and that turns out it's 36. And then you can, to get rid of that, you square root, and you do it to both sides. You're doing the opposite, so that cancels, and you just get a equals 6. So it's the same type of idea, except for instead of figuring it out on this side, you're figuring it out on this side. Like if you were to do it, like let's say, so something that doesn't work out nicely. If you have a triangle that looks like, let's say this is 7, this is 11. This would be the hypotenuse. That would be c. So it would be like a squared plus b squared equals c squared. I'm just going to call this one a, this one c, and this one b. So we want to figure out what b is. So 7 squared would be 49. So I'm going to do 49 plus b squared equals, and then 11 squared, 11 times 11 is 121, I think. And then I would, like, the rest of it, I would just do in the calculator from here. So, like, I have my 49, I have my 121. Really, I'm just going to subtract this. I'm going to take this and then move it over here and subtract it.
Yeah.
So that's really what I'm doing.
That's it.
So, yeah, so I would just be, like, from this part, as soon as I figure out this,
Those 2 steps first.
those
and
two
then,
squared, then I would just go to the calculator and then do
yeah.
121 minus 49 equals, that's 72, and then I would do the square root button. So 8.485.
Got it.
So then I would say this one equals 8.485 or whatever it was. Does that make sense?
Can you scroll up to that just that problem so I can take a photo?
Sure.
Because I always fuck up on the.
Yeah, I started recording it again, so I'll send you the video of this when it uploads.
Well, I just wanted, because you know how I always forget, like.
Yeah.
It'll be like the last step, the squaring it or something, you know, at the end, and then writing it. If I'm writing it out, you know.
Is there anything else that you want me to like scroll back to?
Oh no, that was it. I just wanted to keep capture that one that you solved the whole problem,
Okay.
The whole thing. That's it. So I'll try to do one tomorrow or something.
Okay, and then
Watch videos.
if you, I'll be free tomorrow too at 8. So.
Okay, yeah, me too. So if anything comes up, just let me know. Yeah, whatever.
You do the same.
Thanks, bro.
All right.
Have a good night.
You too.
Bye.
Bye.